So today we're going to start off, and I'm going to give you quite a bit of abstract math here, trying to think about some of our laws of logs. So we're just going to talk about two laws of logs. And I'll go ahead and work through this, and then maybe at the end you can press pause and re-look over your work, and then let me know if you have any questions tomorrow in class. I'm going to pick some variable x, and I'm going to say that variable x is equal to a to the m. So three variables in this equation. Then I'm also going to say that I have another variable y, and I'm going to set that one equal to a to the n power. So if we thought about it and practiced our skills, we could write this. This is an exponent form. We could actually write this in log form. So if I'll start here with this one, to write this in exponent form, or I'm sorry, it's written in an exponent form. To write it in log form, we would look at our base first, our base being a. So we would write log base a of our answer, which is x, and that equals m. So those two statements, one's in exponent form, one's in log form, mean the same thing. Now I can do the same thing for this exponent statement here and switch it into log form. Again, identify your base, which is still a. So I have log base a of my answer, which is y, and that's all going to equal n. So now from here, I want you to think about what would happen if you took x and we multiplied it by y. Well, we know what x is. X is a to the m, so I can just write out a to the m. I'm going to multiply that by my y value, which is a to the n. Now, when we're multiplying and we have the same base, what do we do with our exponents? Oh, very good. We add them. So x times a equals a to the m plus n. Now, I'm going to go ahead and switch this back into log form again. So now I have my answer here and a base. Now I'll look at my base again, my base being a, and over here I'll write my log statement. So this means the same thing as log base a of my answer, which is x times y, and that all equals my exponent, m plus n. And that's just following kind of what we know already so far. Now I could actually substitute in, I know log base a of xy. Instead of writing m, I can substitute in everything I know that's m, which is log base a of x. Now instead of writing n, I can substitute in what I know of n. And we know that n equals log base a of y. So now basically, this is your first law of logs. If you have the log of base a of two numbers being multiplied, we can rewrite it as the log of base a of x plus the log base a of y. And we'll do an example like that. I just wanted to talk one more rule before we move on. So our second law of logs is, I'm going to start off the same exact way. I'm going to say x again is equal to a to the m. Then I'm going to pick a y value, and I'm going to call that, once again, a to the n power. From here, we can write this in log form. So I'll start off with this first one. To write that in log form, I would say log of base a. And that is of my answer, which is x. That all equals m. Now I'll write this one here in log form. So I have log of base a of y equals n. So now that, again, I have two different equations expressed two different ways. One in exponent form and one in logarithmic form. So now instead of multiplying my x and y, what would happen if I divided x and y? Well, we can substitute in what we know for x. X is just a to the m. and my y value being a to the n. And what happens then when you have the same base and you are dividing exponents? Yep, you got it. It's a to the m minus n. So that's x divided by y. And now from this, we can go ahead and write this in log form. So that could be written as, identify your base once again. Our base is just a. So we have log base a of our answer, which is x divided by y, and that equals m minus n. So now we can substitute in our values for m and n. I know that m is, look back up here, log base a of x, so I'll write in log base a of x. And I know n to be minus, our n is log base a of y, log base a of y. And if I put in my equation here at the front, if I have log base a of some value x divided by y, then that's writing the same thing as log base a of x minus log base a of y. So what do we do with these now that we have these two laws? Let's look at two examples. This first example says write as a single logarithm. If we notice here, we have a bunch of logs that are added. We can look back at our slides and try to figure out, what do we do when we are adding logs of all the same base? All of these logs have a base of 10. They're not written because we assume that you know that they're there. But since they all have the same base, we should be able to combine them. And here before, we said if we have the same base and we are adding logs, we can multiply our values, x and y. So let's go back. This means this is the same thing as log of 2 times 3 times 4. So I can simplify that to be log of, we have 6 times 4, which is 24. So log base 2 plus log base 3 plus log base 4, using what we just we're showing, is log of 24. Okay, now let's look at this one. We have the same base, log base 2, and log base 2. Since they are all the same base, we can combine them using the laws of logs. We know, to start off with, we always work left to right. If we have two logs that are added together, we'll look back here. If two logs are added together, we can combine them by multiplying x and y. So I could write this as log base 2 of 7 times 5 minus log base 2 of 6. So this is the same thing as log base 2 of 35 minus log base 2 of 6. Well, now I have the log base 2 of 35 minus log base 2 of 6. Well, since we have the same base, we can combine them. But now we have subtract. If we look back to our last slide, when we subtract two logs, we combine them by dividing those values, x and y. So let's apply that here. So this would be log base 2 of 35 divided by 6. Since we can't simplify any further, that's it.